Solving cubic equations. Now that we know the factor theorem and can factorize cubics, we can go on to solve cubic equations. Note, a cubic always has at least one real root, so we can always reduce a cubic to a linear and a quadratic factor like this. That's because a cubic is shaped like this, or possibly it's one with a horizontal point of inflection. But because it's going to go off the bottom of the graph here and off the top here, it must at some point cross the x-axis. You can have 1, 2, or 3 roots. One root will come from the linear factor. So for looking for roots, we're saying that px plus q ax squared plus bx plus c is equal to 0. So one root comes from the linear. We want the value that makes that equal to 0, which is x is negative q over p. Using the null factor law, any other solutions must be derived from the quadratic equation. So that's when this bracket here is equal to 0. A quadratic equation may yield 0, 1 or 2 solutions. Remember the discriminant. And if we just draw the picture, we know that a quadratic could come down and have 2 distinct roots like this. It could just touch the axis, in which case it has 1 root, or it could be up in the air like this and never cross the axis. And we can determine which of these situations it is using the discriminant. If b squared minus 4ac is less than 0, then we get this situation that I drew in orange, and we get no real roots. If b squared minus 4ac is equal to 0, we get 1 real root, so that's the situation I drew in green. And b squared minus 4ac is more than 0, so it's positive, we get 2 real roots, and that's the situation I drew in yellow. Now remember that b squared minus 4ac is the part that's under the square root in the quadratic formula. So if b squared minus 4ac is negative, then we take in the square root of a negative. And that is not a real solution, which is why we get no real roots. If it's equal to 0, then basically this reduces to just negative b over 2a, so just one value. And of course, if it's positive, then we get negative b plus that value and negative b minus that value on top, and therefore we get 2 real roots. The quadratic may be solved by factorizing and using the null factor law, or by using a method such as completing the square or the quadratic formula. From the above, we can see that cubics may have 1, 2 or 3 roots. If we've got px plus q, ax squared plus bx plus c is equal to 0. Just tidy that. Then one root will come from here, and from the quadratic, as just discussed, 0, 1 or 2. So if we add the roots, we get 1, 2 or 3. We may not be told the linear factor, and so we may need to search for it. We do that using the factor theorem. If the cubic is px is ax cubed plus bx squared plus cx plus d, a systematic search is to try the factors of d. So we evaluate p of 1, p of negative 1, and so on. Let's suppose that d was equal to 6. Our factors will be 1, 2, 3, and 6. And so p of 1, p of negative 1, p of 2, p of negative 2. And remember, we're looking for it coming to 0 by the factor theorem. In practice, we may need to look for plus or minus factor of d divided by a factor of a, where a is this number at the front. But you are unlikely to get a question where you need to go to this extent, because if you get one of those, you're going to be searching for that linear factor for ages, and usually that's not the point of the question.